with reading and highlighting key words. A circular wheel has a diameter of 30 centimetres. The wheel rolls a distance of 60 metres. Calculate the number of complete revolutions completed. So I've highlighted the bits of key information, and because there is not that much information given in this question, I am going to draw a diagram. So the first part of the diagram is going to be the circle. It is a sketch, it is not an exact drawing. I am then going to add the diameter of the circle, which is going to be 30 centimetres. The question then assumes we know how a wheel rolls and what relevant equation we need to use to work out how many revolutions this circle does. So let's say the wheel rolls from this point to this point, and this is going to be a distance of 60 metres. Obviously this isn't drawn to scale. And now we need to think about the different equations we know to do with a circle. So if the circle is rolling from this point to this point, rather than calculating the area, which is the inside of the circle, we're obviously wanting to think about the circumference, which is the perimeter of the circle. So we're going to say that if the circumference of a circle is equal to pi multiplied by the diameter, one revolution is going to be just pi multiplied by diameter. So this is going to be one revolution. We want to work out what we need to multiply pi d by to get to 60 metres. So I'm going to say pi d multiplied by r, where r represents the revolutions, is equal to 60. And the idea of this question is to work out what r is equal to. So I'm going to rewrite this equation, and this time I'm going to substitute d for the value we have for the diameter, which is 30. However, it is probably not best if we use 30, because we would like both dimensions given in the question to be matching. So we would like the 30 centimetres and the 60 millimetres to have the same unit of measurement, but they don't at the moment. So I'm going to say we're going to change the 30 centimetres and we're going to convert that to metres, because we need to be consistent when we're working through equations. You could have done it the other way. You could change 60 metres into centimetres, but it's quite easy to change 30 centimetres into metres. So we've got pi times 0.3 times r is equal to 60. We then want to rearrange the equation to isolate r on its own. So to isolate r on its own, we need to reverse the process of what r has gone through. So r has just been multiplied to pi and then multiplied to r. So to reverse that process, we're going to do the opposite, which is to divide both sides by 0.3 pi. So we're eliminating two of the terms on the left hand side, and we're going to combine them onto the right hand side. Normally in a question like this, when it doesn't specify what pi is equal to, just use pi on your calculator. So we now have r is equal to 60 divided by 0.3 pi. Typing that in the calculator, we are going to get an answer. We are probably expecting an answer which will not be an integer, so the answer is not necessarily going to be a whole number. And as expected, I have got as an answer 63.66 revolutions, and it continues the numbers, but I'm just going to put some dots because we do not need to know, say, beyond this point. but the question's asking us for the complete revolutions. So this has shown that after 60 metres, this circle has turned 63 and a bit times. So the number of complete revolutions is going to be 63.